And we know we have assumed this value of delta in the derivation of single amplifier. Delta is the fractional frequency variation. How much the frequency is varying from the center frequency f naught or omega naught. So delta will be omega minus omega naught by omega naught, or it is f minus f naught by f naught. Any expression we can take. So now I am going to take in terms of f. So consider this here. So I substitute for delta. So 2 into f minus f naught by f naught into qe equal to plus or minus root of 2 power 1 by n minus 1. So I have f minus f naught here. So 2 into f minus f naught into qe equal to plus or minus f naught into root of 2 power 1 by n minus 1. So this is a general expression. We have to see how this expression is going to be for f1 and f2. F1 is the lower cutoff frequency and f2 is the upper cutoff frequency. So when you put f is equal to f1, this difference, f1 comes always before f0. So this difference will be a negative number. Okay. So this difference will be a negative number. So 2 into f1 minus f0 into qe equal to minus f0 into root of 2 power 1 by n. So plus or minus is there, right? So it plus is going to be for one frequency, minus is going to be for another frequency. So for which frequency it is plus and for which frequency it is minus, you have to logically relate. When you put f is equal to f1, see this is the bandwidth frequency response graph. So this is center frequency and f1 is somewhere here. So first comes f1, then comes last comes your f2, and in between you get f0. And in between you get, so if you do f1 minus f0, the difference will be negative. So that is what you see here. F0, so they are interchanging the thing. So they write f0 minus f1 equal to f0 by 2 qe into root of 2 power 1 by n minus 1. So minus sign on both sides will get cancelled. This is one equation. The same equation I am going to replace f by f1 and f2 and see what is the change. If I put f2 here, f2 comes after f0, so difference is also going to be positive. So see here, f2 minus f0 equal to f0 by 2 qe into root of 2 power 1 by n minus 1. So I have two equations in terms of f2, f1 and f0, and bandwidth is going to be f2 minus f1. Bandwidth is going to be f2 minus f1, but I have f2 minus f0 and f0 minus f1. So I'm adding and subtracting f0 here so that I get this form. So f2 minus f0 plus f1 plus f0 minus f1. So if you simplify, this f0 and f0 will get cancelled. You will get back f2 minus f1. Okay, since I have the expression in terms of this, or even from this, you can find f2, f1, and you can substitute. Okay, that is also correct. But already we have an equation. If we write the expression in terms of this equation, I will just substitute the RHS alone. Okay, so I write f2 minus f1 as f2 minus f0 plus f0 minus f1. So f0 gets cancelled. So it is f2 minus f1. So this, you have to add the two expressions. The two expressions same. So f0 by 2 qe into of 2 power 1 by n minus 1 plus the same expression f by 2 qe root of 2 by n 2 power 1 by n minus 1. So 2 times, so this denominator 2 and numerator 2 will get cancelled. So you get f0 by qe into root of 2 power 1 by n minus 1. And f0 by q is bandwidth. So f0 by q is a bandwidth of single stage. And what we find is the bandwidth, overall bandwidth of the amplifier. So B1N, 1N means single tuned N stages. P1 into root of 2 power 1 by N minus 1. So very, very important expression. So we see that the bandwidth of the cascaded amplifier is the individual bandwidth multiplied by this factor 2 power 1 by N minus 1. And see here, N is the number of stages. That is the dominant factor here. So N will decide how much the bandwidth will decrease.